Good morning, everybody. Back again with another lesson in solutions. So today we're going to be discussing the concentration of a solution, which involves the mathematics of solutions. And there are two ways to calculate concentration, but today we're only going to focus on the one that we need, which is molarity. So let's get into it. Once a solution's made and classified, the chemist needs to quantify the amount of solute dissolved in solution. This gives us the solution's concentration. So if I'm looking for the concentration, I want to know how much of the solute has dissolved in that amount of solution. Now we can relate this to many things that we do at home, making iced tea, making Kool-Aid, making lemonade. If I'm going to mix a solute with water to make a solution, I can determine what the concentration actually is going to be. Now, when we're doing this, we're going to represent our concentration which is molarity. And molarity's symbol is capital M. And thankfully for us, this is on our reference table on table T. So if you don't have your reference table out yet, hit pause, grab it, because we're going to need two things, our periodic table and our table T. So if I jump to table T, you'll notice that in the concentration spot right here, there are two mathematical formulas. We're not going to use the top one. We're only going to use the bottom one. That says the molarity is equal to the moles of solute over the liters of solution. Again, that's right here, moles of solute over liters of solution. So if I know it's a concentration problem, and I know we're using molarity, which is on table T, this should be something that we can look up and identify right away. And again, it's moles of solute over liters of solution. So because this is a mathematical process, when we do these problems, they are pretty easy unless we're given some questions that involve some extra work. And in this PowerPoint video, you'll see that some of these are very quick and easy to do, and then some just take a little bit more time because there's some extra work involved. But we'll go through every type of problem in the process. Now, when there's some extra work, three things could happen. One, because the formula is moles over liters, sometimes they're not going to give you the amount in moles. They will give you the grams that are in solution, and you're going to have to change it to moles. And notice, thankfully, this is also on table T. So it's something that we can look up, and it's easy to do. So back to table T, notice we have this thing called the mole calculation. Tells me to find the number of moles, which I need for molarity. I take the given mass in the question, and I divide it by the gram formula mass, which we know is just adding up what the formula actually weighs. So if I know I'm going to take the given mass and divide by the formula mass to get the total, I can find the moles. And when we carry out this calculation, we always get on the round side of small numbers. So we're going to round to the 10th if it's less than 1. All right. So because this is extra work, and you may not remember how to do this, we're going to do some examples doing this part of the calculation first. So here I have a question. How many moles are in 20 grams of water? Now notice it's asking you for moles, and they're giving you grams. So I know it's going to be a find the mole question. So in order to do that, I'm going to have to do the formula mass. I already have the given number here, but I don't know how much water weighs. Maybe you forgot, but we could figure it out. Because water is H2O, there's going to be H's and O's in this formula. And what I need to do first is look up what H and O's masses are. So H on the periodic table is 1 and O is 16. So let me just show you that so that way you know exactly where these numbers are coming from. H has a mass of 1.00794, we're going to use 1 to make it easier. O is 15.9994. We're going to make it easy, say 16. So if H weighs 1 and O is 16, notice what we're doing is, because there's two H's, H2O, I multiply 1 times 2 and get 2. Because there's only one O, it's 16 times 1 is 16. And I'm going to add those together. That is my total. So I need moles. So I'm going to take the given number 20 and divide by the total, which is 18. So 20 divided by 18 comes out to 1.1. Notice I'm rounding here to the 10th. So that way we have all the same answers as we go through. Not a hard process, just involves some work using the reference table and some simple mathematical skills. Again, you may want to pause this, watch this slide one more time in order to get a better understanding of the process. But I do have another problem for us to work on. So let's take a look at number 2. How many moles are in 35 grams of Na2O, sodium oxide? Again, I'm looking for moles. It's asking me or telling me that I have grams. So I know this is a mole calculation. So same thing we did before, Na2O, Na and O are my two elements. 23 and 16 is the mass. We just had O before, but let's take a look and we'll check it out. Na says 22.99. We round it to 23 to make it easy. O we know is the 15.99. We round to get 16 to make it easy. So 23 and 16 is what I looked up. Times 2 for Na, because there's two Nas. And 1 O, so it's 16 times 1. So that's 46 and 16. I add it up, I get 62. So to find the moles of 35 grams, I'm going to take the 35 and divide by 62. That gives me an answer of 0.6 moles when I round to the 10th. Again, we don't always have to do this process, but if it comes up, it's something easy to do. We just can't plug in any number because that would give us an incorrect response. Now, that's the first extra thing that could happen. The second extra thing, which is much easier to handle, is changing milliliters to liters. A lot of times in these problems, they don't give us what we need, which is liters. They'll give us milliliters. So to go from milliliters to liters, I just simply divide by 1,000. Now, I know some people are good at just moving decimal places over. You can do that as well, but I prefer plug it in the calculator, divide by 1,000, so you make no mistakes. So here I have two examples to work on this process. Notice I'm going to change 45 milliliters to liters. So I'm going to take 45, divide by 1,000, and I get my answer. Now again, those of you who are good with this know if I just take the decimal place here and move it 3 spots over, I get the same answer. Either way you do it, doesn't matter as long as you have the right amount. The second one, changing 125 milliliters to liters. Take 125, divide it by 1,000. That is going to give you 0.125. Again, this is the easier of the extra processes that you might need to do. Again, you have to check in the problem to make sure it's liters. Otherwise, you can't move on until it is. The third thing that could be extra is if they ask us to solve for something else besides the molarity. This sometimes proves to be hard for students because of solving an expression algebraically, solving for x. We know that if something's missing, I can make that variable x, and hopefully you should be able to solve and reset up the equation so that it works for you. Now, how does this work if we needed to review? We already know that when it comes to molarity, it's moles over liters. So if I'm solving for molarity, I don't do anything different. I just make sure I have moles and liters and plug it in. But if I'm solving for, say, moles, for example, notice what I did. I kept the molarity. I made moles x, left liters. And then I have to ask myself, how do I get x by itself? And we know in math, to get x by itself, you always do the opposite mathematical function. So it's divided over here. So I'm going to multiply it across. And that's why it's x is equal to the molarity times the liters. So that might be something we need to do. The last thing that we could be asked for is to solve for a given volume. Well, same thing. If I know it's moles over liters, I make the volume x. And then I solve for x. Again, I'm going to multiply across, so it's x times molarity equals moles. But then I need to get x by itself, so I divide back by molarity. So these are the two other formulas that you might need. And what you may want to do is go to table T and write them in the same spot. So that way you don't have to keep doing it over and over again. That might be of assistance to you. Again, most of the time, we're going to use the regular one. Once in a while, we're going to use and solve for moles. And then on the rarest occasions, we solve for the volume. Again, not hard to do, but we have to make sure we understand the process and we check all of our numbers before we plug things in. So from this point on, we're going to be doing examples going through molarity. And I do have problems that ask us for different pieces. So again, you may need to pause, really focus on what's happening, and then you're ready for your practice. Let's take a look. Okay. When we do these mastering grams to moles and milliliters to liters, these molarity calculations are simple to do. Very important, as we've been doing all along, you want to underline your key information. And we remember, we only need to convert if we need to. If we don't, we leave the numbers the way they are. So let's take a look. Number one, what is the molarity of a solution that consists of 0.25 moles of solute in 1.5 liters? Again, underlining key things. I need molarity. They gave me moles. They gave me liters. Now, in these problems, I always find it best to, once you underline the key points, write out what you underlined. So, moles, 0.25, liters, 1.5, and I'm looking for molarity. And again, instead of using molarity, I use the symbol for capital M. Now, I have to check to make sure my units match the formula. My formula is moles over liters. So I have to ask myself, do I have moles and liters? And if I come over here, I do have moles, I do have liters. So this is one of the easiest problems. There is no extra work. All I have to do is plug it in and solve for the molarity. So that would give me 0.25 over 1.5, which gives me a molarity of 0.16. Again, the easiest problems, they involve no extra work. Make sure you're underlining, you're labeling your units, checking them to make sure they fit, and then plug it in and solve for the missing piece. Let's do number two. Number two says, what is the molarity of a solution that consists of 25 grams of NaCl in 1.2 liters? So as always, molarity, 25 grams of NaCl, 1.2 liters. I know it's a molarity problem. Molarity is what I'm looking for. I have 25 grams of NaCl, 1.2 liters. I know the formula on table T is moles over liters. But when I check my units, I don't have moles, but I do have liters. So this question involves one extra piece of work. So I have to change my grams to moles first. That we did on the previous slides. I need to look up what Na weighs on the periodic table, 23, and chlorine's 35. Again, just to make sure you understand, Na is 23 and chlorine is 35. That's where those numbers come from. Now, in this case, they're both 1, so I'm not multiplying anything by 1 here. I could, but it's the same thing. I get 58. So to get moles, I take the mass that's given, 25, divide it by 58, which is the whole, to get my moles. That is not my answer. That's going to help me get my answer. So I know there's 0.4 moles of NaCl. So now I can plug it in. So it's going to be 0.4 moles over 1.2 liters, and I get my answer, 0.33. Again, this one required one extra piece of work, changing the mass of NaCl to moles. Let's take a look at another one. What is the molarity of a solution that consists of 100 grams of NH3 in 325 milliliters of water? So I'm going to underline molarity, 100 grams of ammonia, NH3, 325 milliliters. I want to write these things out. Molarity is what I'm looking for. Ammonia grams, NH3 is what I have, 325 milliliters. I know my formula. Do my units fit in right away? I have grams. I need moles. Nope. I have milliliters. I need liters. No. So in this problem, I'm going to have to do 2 extra pieces of work before I get my answer. So the first thing is mass to moles. Well, here, N, if I look it up, is 14. H is 1. But now there's numbers. So because there's 1 N, it's 14. There's 3 H's, so it's 1 times 3 is 3. So my total is 17. So to get the moles, I take the given number, which is 100, divide it by the total, 17, and that gives me 5.9 moles of NH3. Now again, that's for the moles. I also need to change milliliters. So all I got to do is take my 325 on the bottom, divide it by 1,000, and I get 0.325 liters. So now I have moles and I have liters. I can plug it in. So that's going to be 5.9 over 0.325. In this case, I'm getting 18.1. Okay, again, moles over liters. Again, this problem involved us changing 2 of the components. Again, these are the harder ones because it requires 2 extra steps. Let's take a look at the last problem. How many moles of solute are needed to make 1.5 liters of a 2.5 molar solution? Step 1, underline. I'm looking for moles. I have 1.5 liters. It's 2.5 capital M. Second step, let's write it out. My molarity is 2.5. I'm looking for moles. Liters is 1.5. I know my formula, but I'm looking for moles this time. So this is the third type of problem for extra work. I'm putting in my X for the moles, so that way I could solve for it. Check my units. I have moles is what I'm going to get. I already have liters, so all I do is plug it in. 2.5 is molarity. I'm looking for X over 1.5. As we did earlier, to get X by itself, I'm going to multiply across. So X is 2.5 times 1.5. That gives me 3.75 moles. Usually, when it's a question like this, where you're solving for X, the units are already correct for you. That's because it's hard enough to manipulate the formula to get X by itself. So you're never going to be asked to do X, solving for X, and then changing units. It'll be one or the other. All right. Now, again, this is not something that gets easy the first time. It could, but you may want to just practice these problems to make sure you understand why we're doing what we're doing, as always, before you go on to the worksheet. All right. I hope this finds you well in this time. And please make sure to watch it as many times as you want and then